Hi everyone, and welcome to another episode of Mr. Carlson's Lab. So it's been a little while since the last restoration video being that Belmont 636 radio receiver. So as soon as that Belmont radio receiver was taken off the bench, the next restoration was put on the bench. It's not what's behind me right now, but there was another restoration started right at that time. That has been almost a continuous restoration since that day. So the day that that video was produced, I started right in on the next one. So it's turning out to be a very in-depth restoration. So as you know, when I buy something to do a restoration on, I just put it on the shelf until it comes time to do the restoration. Then I take it off the shelf and then we experience what's inside this and what's happened to it over the years together. So I know as much about the device on the inside as you do at that point. And this next video that will be produced on that restoration will be a very good example of that. Everything was going great until I flipped the chassis upside down and I was like, wow. So very, very in-depth restoration. You'll remember that wow in the video. You'll hear me say that. Lots and lots of stuff to do. So that restoration is coming up very shortly. For now, since it's been such a long time since the last video, I'm going to share a Patreon video with you guys, and this is part of the Electronic Troubleshooter series. So in the Electronic Troubleshooter series, what I'm trying to do is pass on my skill set to you guys to make you a more efficient troubleshooter, either with vacuum tube electronics, solid state electronics, radio receivers, transmitters, amplifiers, all sorts of different things. And this is just one video in that series. In fact, there's a lot of videos up on Patreon. There's over 50 videos up there right now with lots of different projects and inventions and in designs and all sorts of interesting things I'm sharing up there. So if you enjoy this video, you might want to head to Patreon and check that out. I'll put the link just below in the comments section. I'll pin it right at the top of the comments section. So just click on that and it'll take you right there and you can check it out. So without any further delay, let's get started in this video. Hi everyone. So here's the scenario today. You have a musician client that comes over to you and says he just bought this Fender twin reverb amplifier and he doesn't really know its condition. It works really well. He's going to be taking this thing on the road with him and he wants it to be very dependable. He doesn't want the thing to break down while he's on stage or something like that. So he wants you to go through this thing and make sure that it's working okay and that, it's up to spec. So anything that needs to be replaced, replace it. He says the person that he bought the Fender amplifier off of says it's pretty much all original. So now's the tough part. You're going to ask yourself, do you want to take this job on? You're looking at the thing. It's an older Fender amplifier. He says that it's all original, but do we really know that it is? Maybe somebody's been in there and tampered with it. So at this point, you have a bunch of decisions to make before you take the job on. First of all, are you going to want to get into this? Because if it is all original, chances are there's going to be a lot of things that need to be replaced. So one of the things that you're going to have to warn your client about is you're going to have to say, hey, listen, if this thing is all original, there are a lot of components inside of an amplifier like this that could potentially be bad. So if they are bad, it's going to run up to a pretty hefty bill, especially if you have to replace all the electrolytic capacitors and say there's some bad tubes or something like that. And, who knows if all the potentiometers are working, are the jacks tight, it just blah, 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 it goes on and on and on. And, is reverb tank working? It's, there's so many things at this point. So you can ask him, did you try the reverb? Does it work? And he says, well, yeah, it works. And you can ask him about the vibrato. Say, does it work okay too? And he says, yeah, it seems to be, pulsing like it should. So that gives you a good idea at that point. Okay, so he says the thing is working and it sounds like he knows what he's talking about. So maybe it won't be so bad of a job. Another thing that you have to keep in mind before you take on a job like this is amplifiers like this, they have a lot of high voltage in them. Even the solid state ones, have got high voltage in them as well, because they're, big amplifiers, right? Not as high as a vacuum tube amplifier, but there is still high voltage present. And of course, if the thing plugs in the wall, there's always that danger as well. So you have to keep that in mind. Are you comfortable with working on a vacuum tube amplifier, or are you comfortable working on any type of an amplifier that's going to have substantial voltage and current present? Another decision that you're going to have to make before you take on this job, depending on what you want to repair and what you're going to really focus on, right? So those are the things that we're up against right now. So obviously me, of course, no problems. I'll take this thing on. And as you can see here, these two screws right here and those two screws right over there are all it takes to get this amplifier out. Now don't kid yourself, when you look in the back side of this thing, you're going to see a really heavy transformer. You're going to think, probably tipping this thing on its side or something like that is going to make it, a lot easier to get that amplifier out. Well, no, it isn't. You have to leave it up like this. You have to leave it exactly the way it is. You have to undo these two screws here, these two screws on the other side. There's a little black panel on the back that you can take off and loosen up the line cord, unplug the jacks, and then at that point, the thing, you kind of push the amplifier forward, drop it back, and then take it out. It'll spare you from all of that because it's, a little bit time consuming to get that thing out of there. If you try and tip it upside down and think it's going to make things easier, no it won't, because this here will hook on the speaker grill. So it has to be up this way when you take these things out. Another thing that you want to be very careful of when you remove these amplifiers is as soon as you remove this thing, if it's been recently powered up or powered up even a long time ago, there's a good chance that the capacitors could have a charge and the chassis is open on the top side. So when you're dropping the amplifier out, you want to make sure that you definitely don't stick your hands inside the chassis. Of course, you want to make sure that the tubes are cooled off and take all the precautions so that you don't zap yourself. You don't want to be putting your hands anywhere where you could be giving yourself an electric shock. And I'm going to show you some other hints and tricks on working on these types of amplifiers. Some really common things that people do that you would never suspect that'll give you a really bad shock on these amplifiers. It's just something that you just don't think about. So I'll clue you in on that here in just a moment as well. So what I'm going to do now is I'm just going to get the amplifier out. I'm going to move the camera over to the bench here, and then we'll go inside this thing and we'll slowly go through it, and I'll tell you exactly what you really need to address in a project like this, and just to make it dependable, so the fella is happy, he or she is happy, whoever is going to be taking this thing on the road, so that the thing doesn't fail when they're on stage. There's nothing worse than that. If you recall on my regular YouTube channel, you'll see that large Thorderson amplifier. Things like that, you don't want that to fail on stage because the person is depending on that, and of course they're using it in a show, and of course you wouldn't want the fella to be going quiet, mid-song or something like that, right? So depending on the musician, some musicians, want a patch if they just practice at home, or if they're, just, taking this thing to small gigs, or, just taking this out to practice with their friends. Other people are taking this out to live events, and those are the people that will say, I'll shell out whatever type of money it takes to make the thing dependable. So, put all the best parts in it and things like that. All right, I'll get that amplifier out of there and we'll move to the bench, and I will shut this Rode microphone off. This is a mobile microphone. I'll shut the Rode off and I'll be back on the vacuum tube microphone here again in just a moment. What is the first thing that we notice looking at the top side of the chassis? Well, the first thing that I can see, the thing that really sticks out, is that we have some mismatched 6L6s. Now, because of the angle of the camera, you can't see everything that I see, but I'm going to show you that here in just a moment. So one of the other things that we want to do is take all of these little tube shields off. They're very easy to get off. Just push down, give a twist like this, and we can take a look and make sure all the right tubes are in their right sockets. That's another thing that we want to do. So what we'll do here is we'll take a look at this vacuum tube here. This is a 6L6. This is one of the output tubes. See how easy that comes out? It's not supposed to happen like that. These have been opened, I guess you could call it, like this. They've pressed down on these spring retainer clips so many times that they're not even grabbing onto the base of the vacuum tube anymore. You can see they did at one time. Another thing that we can immediately see is somebody has broken the index pin off. So these tubes have been out by somebody that's been a little bit meat-fisted and, it's been really rough on the tubes. These are Fender vacuum tubes. We can also see, if we look here, see that there's a crack in the Bakelite base. The reason there's a crack there is because these tubes get as hot as the blazes of hell. And this thing is upside down like this because the amplifier is sitting like this, right? So these are hanging upside down, so all the heat from the vacuum tube rises and it cracks the bakelite base after some time. So that's not necessarily a bad thing. It just means that the tube's got quite a bit of time on it. In some extreme cases, if the biasing goes bad or, the bias circuit goes bad, it'll do this more extreme and get them all over the place, but you'll usually see a dime mark on the plates, things like that, or when it's been overheated. It's usually pretty easy to tell when the biasing has gone haywire. Getter compound in these tubes is really nice still. So there's a chance that these tubes are still good. It's just, they've been really abused. You got to be really careful once those index pins are broken off. You have to look for, where the little index pin is supposed to be. You can see how there's a little bit more here. You can tell that the little index would come down on this side. You would have to make sure that that goes into the tube socket correctly, and you can see somebody's marked that right there. So you want to put that to the index right over there. If you plug this in the wrong way, bad things happen to the amplifier. So there's one there. Let's take a look at the next one. Again, these things aren't even holding the tube, so these are supposed to be nice and tight on the tube. These have been out a bunch of times. Another broken index pin. So this amp has seen better days. You can see its little mark would be there. So if somebody marked this one, nope, nobody marked this one here. So if you have tubes like this and they're still nice and strong, but the index pin is missing, you take a little file and just file a little notch in there. Even after you file the little notch, just a couple of rubs of a small file like that, you can take a little bit of liquid paper, smear it in there, and then scratch the rest of it off, and it'll make a nice little white line on that tube, and it'll help you align it to the actual index mark here. You might want to make sure that these things are tight as well. That's something that you would warn the owner about. In this case, the tubes will just get replaced. These things are probably got lots of time on them, right? Here's a tube that looks very familiar. This looks like one of the ones that I just replaced in that other amplifier in the last video. It is. It's just like that vacuum tube, actually. What's really odd is I rarely ever see these. I rarely ever see this particular type of vacuum tube, and here's one in this amp. That's just really strange. Index pin on this one. Getter spot looks really nice. Chances are this is probably the strongest tube out of the lot. And let's see the last one. Does it come out? Yeah, it does. Everything is so loose here. And the index pin is still on this one. And who knows if it's tired or not. Really can't tell. These little teeth here, they got little teeth that grab onto the bakelite base. They have been grabbing this at one time. It's just that these tubes have probably been out of here a whole lot. Somebody was just a little bit nicer to this one. They probably used these two as practice, broke them off, and thought, oh, maybe I should actually try and hold these retainer clips down and very gently rock this out. So far we know that, this thing has definitely seen some rough times. It's a really big amplifier. This amplifier makes 135 watts RMS. It says right on the back side here, the output power. So that is a lot of audio output power for 4 6L6GCs. So they're obviously running some pretty good plate voltage on this thing, and judging by the size of the audio transformer, or the power transformer and the audio transformer, I should say, this thing is not light. Look at the size of the core on this thing. Use a 6L6 as comparison. Just huge, right? So audio transformer the same, really big audio transformer. So definitely designed to make some noise. There we go. So another thing that you could do, since this thing has lots of time on it, is take every single tube out and test them in an appropriate tube tester, or you can use the circuit itself to test the tubes. It's a good idea to test them for microphonics and things like that. So when you power the amplifier up, you want to just do this to all the vacuum tubes, and if one is excessively noisy, now keep in mind that they will be a little bit microphonic, all right? So, tubes always make just a little bit of noise when you tap on them, but if you're, doing this and it's going ping, ping in the speaker, what that'll end up doing is creating feedback and causing the amplifier just to make lots of noise on its own. A tube like that would definitely need to get replaced. This cap here is something that really needs to be thought about before being removed. So when this thing gets removed out of the case, Again, remember that, of course, the power line is off of this thing, it's unplugged, and you're keeping your hands away from the inside of the chassis, right? You don't want to be poking your fingers around like this, even if it's been off for a while, because the capacitors could be charged up. There are filter capacitors underneath this cover here, and what a lot of people don't think about when they remove this cover is these capacitors are stacked like this under here, and there's usually a piece of black foam or something like that, pressing them down onto a board with a bunch of eyelets in it. There are leads on the ends of the capacitors exposed. So if you take these screws out and those capacitors aren't discharged correctly and you tilt the box over, you can get an extreme shock because you're going to touch the leads with this metal case. Something to keep in mind, and something that a lot of guys don't think about, is making sure that those caps are discharged underneath the chassis, especially when removing this metal cover. There is a chance that you can touch those leads just by moving this. What I'll do is I'll show you that here in just a moment. We're going to go under there and make sure that the capacitors are discharged, make sure that everything is safe before I go about removing this cover. Okay, here we are looking at the underside of the amplifier, and I can see a whole bunch of things already. First thing we're going to do is just make sure that the caps are all discharged. So I'll put the discharger right there. The nice thing about having the plastic box, you just kind of put it any old place. Get the light from glaring off these just in case we can see any LEDs light up. Okay, so we can see that we have a bridge rectifier here. So where the two lines join, we know that that's the positive of the stack. If you're unsure about this, download a schematic on the amplifier and check it out. I'll look for a schematic on this and we'll take a look at a schematic here in just a little bit. And I'll tell you how to go about tracing the signal through this amplifier as well. So here we go. That's looking like pretty good. So now, what you want to do, it's a little bit time consuming, is just go through here and make sure that all the capacitors are discharged. Go through the whole chassis, spending time with each one. These are lower voltage caps, but still, make sure that they're all discharged and everything is okay. And once that's done, you can pretty much start working on there. You also want to monitor this with a voltmeter just to see if it starts to climb again. If you find that you've discharged it and the voltage starts to climb like I've shown you in other videos, simply take a jumper clip and attach that to the chassis so that this stays discharged. You always want to make sure of that. You definitely don't want this thing charging up while it's sitting on your bench and while you're working on it. So I'll go through and I'll do all of that. Once that's all done, I'll flip the chassis over here. We'll remove that cap and we'll see if it has all the original electrolytics in it. From what I can see here already, it looks like this thing has not been touched since the day it's been made, at least on this side at any rate. All the capacitors have been discharged and I'm ready to remove this cap. So let's do this together. Let's see what's hiding under here. It's always interesting to see what hides under these things, get an idea of how this thing's been treated throughout its life. So far from the 6L6s, we know that it hasn't been all that incredibly easy. Every piece of electronic gear tells its own story. If this stuff could only talk, it should have some pretty interesting stories to tell. Okay, so here we go. Not bad. Those caps aren't looking too bad. We'll take a look at those here in just a moment. So as you can see, metal box, exposed leads on the side. All it takes is for somebody just to do that, to move the box this way if these haven't been discharged correctly, and you can see the hazard right there. So always keep that in mind. So I'll just get this thing out of the way here. So the caps, they look original, and they're also looking like they're in very nice condition. Usually they have a little blowhole on the side here, and there's electrolyte squirting out of the sides of these things by now, but look at that. Looking great condition. And the owner of the amp says it does work, so I haven't powered this thing up at all. So I always like to go through it and check it out before I go about powering something up. It's just, who knows? They say it works and all this kind of stuff, but, if I was to open this thing up and found one of these things oozing and there's goop all over the place, of course, there's no way I'd want to turn this thing on. But this is actually looking really nice. So, of course, the caps are old. They need to be replaced. But, they're looking like they're not in too bad condition here, so they haven't exploded or anything like that, so that's a good thing. Now, what I can tell is the cap has been off at some time. How can I tell this? This wire's been squished, and it happens all the time. People don't watch this wire, they leave it here, and then they tighten the cap down, and they pinch the wire, and it shorts things out. And as you can see, it's flat. I don't know if you can see that. Let's see if I can. It's not a light amplifier. Can you see how it's pinched there? And it's pinched here, so this has been pressed down here, and somebody's tightened the cap on. So this has been off. Somebody's been looking under here. Or, some extreme case, maybe it was even done at the factory. Somebody wasn't paying attention. Long weekend, Friday, who knows. So we all know about those kinds of cars. Anyways, another thing that you're going to want to do when you replace these capacitors in here, you can see that these are touching. There's a very thin cover on all of these capacitors. And if the capacitor gets hot, sometimes this plastic splits. These two capacitors here are the main filter capacitors, and they are in series. So what ends up happening is when these things touch like this, if something was to happen and these two shells were to touch together, that just isn't a good thing. So what you want to do when you replace the capacitors is you want to make sure that there's a little bit of space between each one, just like that. So you can see there's a gap between them. Nothing is actually touching. And then what I like to use is, now I'm not endorsed by this company at all, but it works extremely well, and I'll share this little secret with you guys, is I like to use a compound called GE Silicone 2. Now, this is a non-acidic type of a silicone compound that you can put in here. It doesn't have that vinegar smell, all right? You can squirt a little bit of it in between here and let it set up. It sets up very fast, this stuff. So you don't want to squirt so much in that it's flowing down onto this board, because if your new capacitors are ever going to need to be replaced, you really don't want to make it a real pain for the next guy. So you want to just put it between the caps just so that it holds them separate from each other so that they can't touch. You got to remember that these things are in high vibration atmospheres. Like, this thing is 135 watt amplifier. There's two huge speakers that sit directly below this thing. If it's playing in an auditorium, this thing is buzzing wildly. And you don't want these things to buzz together and touch, because even just buzzing together will cause these things just over time from mechanical stress to wear through that plastic case, and these will short out. I've seen it. So you want to just squirt a little bit between there. Now, usually GE Silicone 2 comes in the caulking tube, and you need it to put it into an actual caulking gun and use that. But the stuff is, relatively reasonably priced, and it works extremely well. So something to keep in mind. Never use a silicone that has that vinegar smell to it, especially around aluminum and things like that. Now, this has still got that plastic coat on it, but you just don't want to be putting that around here. I'll let you in on a hint that Kenwood did way back when. Kenwood, the old TS440s, they used an acidic compound in their VCOs, and they'd squirt it around the transistors to hold everything nice and steady, because the radio is a mobile HF radio. It was designed to be moved around in vehicles and things like that. Well, it actually rots the transistors right off of their legs. The transistor, you can go into the VCO box, grab the head of the transistor, TO92, or actually a little smaller than TO92 package, and you could grab the actual transistor and just pull it right off, and it would break right off, and the three little leads would have rust on them. They'd just be sitting there like that. And that's what happens when you use an acidic compound. So they changed that after a certain serial number so that it wouldn't happen anymore. But, the lesson learned the hard way. So very easily indicated on a Kenwood TS440 by the display of the radio just flashing dots. So, at any rate, always a good idea to do that. Another thing you're going to want to do here is, you'll see this piece of rubber that they've put in here. It's a piece of rubber. It's not really a piece of foam. It is kind of maybe a rubberized foam, I guess you could say. It's a little stiffer than like something that you would maybe call weather stripping or something like that, right? You might want to replace this here as well. Put a nice piece in here so that when you put the cap back on, it gently presses down on all of these capacitors and keeps them nice and tight. Again, high vibration atmosphere. This thing is also being moved around in vehicles, right? This thing is so heavy, there's casters on the bottom of the case. When I say heavy, it's heavy. The thing rolls around on casters, and, just this transformer alone, the amplifier chassis alone is heavy. Forget the two huge speakers and the rest of the wooden case and everything like that, right? So you always have to keep that in mind. There's a lot of mechanical stress happening in these things because you have, tubes hanging inside here upside down. You have two huge speakers that are just vibrating. Everything is vibrating on this thing, right? Probably adds a little bit to the effect of the actual guitar amplifier itself. It's what gives these things their personality. And I'm going to get into that as well. Another thing to keep in mind is the personality of the amplifier you're working on. A lot of musicians are very, very particular about this, and it is not our job to try and change their opinion on things. You never want to do that. Quickest and easiest way to lose a customer. All right, so what I'm going to do for now is I'm going to put this cap back on here. Another thing you want to do is make sure that these resistors, a lot of the times these are straight up and down like this, and they're very close to the case. You want to make sure that they're all bent in just like this. So that's smart that these are bent in like so. And you can see I've moved this wire out of the way. It's on top here so that it's not going to get pinched on the box again. I'll put the box back on. I'll flip the chassis back over again. We'll start talking about the bottom side. Looking at the bottom side of this amplifier here, there's a whole lot of things to talk about, and I get lots and lots of questions about guitar amplifiers, and one of the major questions I get is these high-flying filament leads. You can see that they rise up off the tube socket, they kind of jump over to the next tube socket, they go down to the tube socket, and then they have another join, and these ones move over here, and it kind of just works its way along like that. And people say, isn't that kind of frowned upon, that practice? Well, in high fidelity, yes it is, but high fidelity amplifiers are designed different than this, and what they're doing is they're trying to make their system work by doing the high-flying filament lead setup. So what I mean is, in most vacuum tube audio amplifiers, hi-fi amplifiers, things like that, the tube sockets like this are not remote from the components. You can see that we have a board over here with eyelets on it, and all the components are over here, and they have these long wires that are running over to the tube socket. Well, all these long wires are going to end up picking up hum, and that's why they're pressed close to the chassis. The best way to keep the filament leads away from these wires is to have them come up. Now, in the actual Fender case itself, there's a metal strip that's kind of stapled to the top. It's almost looks like a big sheet of foil that's stapled to the top, and when you press the chassis in, it presses down, so it covers up the chassis. If this was left open like this, if you brought your hands close to the top of the amplifier while the amp was on, it would hum. You'd hear it hum. So there's that metal strip. It's again almost looks like a piece of flashing that's stapled to the top side of the amp, and then when you tighten the amp down on the top, it squishes that against the chassis and shields the whole thing. So these wires are actually pressed close to the bottom side, if you were to look at it like that, of the chassis. Now, most of the time in high fidelity amplifiers, these things are tucked away and into corners of the actual chassis. So this would be bent over and tucked into the corner. As you can see, there's a lot of connections and things on this particular side of the chassis. So they have found, by using the high-flying filament lead system, by having these come straight up like this, it's basically just giving them the minimal amount of hum. That's the only reason they're doing that. You can bet that if these had to be bent over here, they would have them bent over here. This is just the way, in production as well, it worked the easiest to get the hum to the absolute lowest. Another question I get about these amplifiers all the time, and I hear this all the time, is like, Paul, you don't have a speaker or a load hooked up to the audio transformer when you're turning the amp on. Isn't that hard on the amplifier? No, it's not, if there is no signal. That's the trick. You can even give it a very mild amount of signal. So, a big amplifier like this thing, putting out a watt or so into basically nothing wouldn't be too big of a deal. This is a 135 watt amplifier. Once you start turning up the gain, say you had a 400 cycle tone running through this thing and you were wanting to test this and you were giving it some pretty high audio levels, yes, that is hard, because the speaker itself, the impedance of the speaker determines the impedance of the other side of the transformer on the plate. So if you change the speaker impedance, you're also changing what the vacuum tubes are seeing on the other side of the transformer. It's not something that only one side of the transformer is isolating the other side. You can look at it as being reflected upon the vacuum tubes itself. Here's the thing that a lot of people don't understand about these amplifiers and not having a speaker hooked up to it. First of all, the transformer, it only looks like a DC resistance if there is no signal. The only time a transformer is working is if there's an AC signal, or these actual vacuum tubes have to drive that tube. So if there's an AC signal on the grids of these tubes, and these tubes have to pass that AC signal, they have to put that power into something, that's the only time it really matters. When the amplifier is sitting quiet, that transformer isn't doing anything because it needs AC on the other side. It's just the vacuum tubes are like, okay, I'm hooked up to a resistor at this point. That's all they're thinking. The minute that you start giving it an AC signal, that's when it starts to matter. So most vacuum tube amplifiers, if you power the thing up with no speaker, there isn't a problem. Now, that's most. There are some very extreme cases where, you know, the feedback network is very touchy and things like that, but these amplifiers here are so incredibly rugged. You test these things on the bench all the time. Again, you can give them a little bit of signal coming in, you know, and if the thing's putting out very little signal at the speaker jack, you know, volt peak to peak or something like that, you know, you're not worried about it. It's not going to hurt anything. If you crank the volume up super loud, you can hear the audio transformer ringing at 400 cycles and there is no load. Yeah, you're probably going to damage something. So it is that fine balance. Now, when I'm talking about the personality of an amplifier, a lot of musicians are very, very, I guess you could say, strong-headed in their thought that, you know, they want to keep the thing as original as possible because they want to keep the personality of the amplifier. They've played lots of different amplifiers. They've played this one, and it's making the sounds that they like. It has that depth, maybe that warmth, the whatever. Us being technicians and engineers, we think, okay, that's all created by the tightness of the speaker. You know, a vacuum tube is simply a valve. It's, you know, we think this way. We're thinking in these terms. A lot of musicians look at these amplifiers almost like they're magic, and it isn't our job at any point in time to try and change that. And you always want to keep that in mind. It's the quickest and easiest way to basically piss somebody off. You don't want to do that. Now, there's a line to be drawn, and this is a very fine line when you're working on amplifiers like this. If this thing had a whole bunch of capacitors in here, and we're going to test these here in a moment. I'll show you a little trick again with this new forecasting tester that I've created. If this thing was loaded with wax capacitors, and the guy's like, well, you know, I really like the sound of it, I don't want you to change those, that's kind of when you have to put the foot down and say, okay, listen, if you leave those wax capacitors in there, what's going to happen is it's going to end up destroying the amplifier. It's going to wreck the audio output tubes. It's going to destroy the power transformer. Do you want that? Another thing to tell them is when the amplifier was made, if it did have wax capacitors, okay, that it didn't sound the way it sounds now. So those capacitors weren't leaking, so they weren't passing DC, so the sound has changed over time. And if you really like the sound of the amplifier the way it is now, if you leave everything the way it is, the thing is going to be undependable on the road, and chances are the amplifier is just going to burn down. It's the way it is. Old wax and paper capacitors, even some of the old paper and oil capacitors that are in these amplifiers are just horrible by now. They're just pieces of garbage and they gotta go. So something to keep in mind. So there is that line, and you have to be very careful the way you approach your customer about talking about this kind of stuff. So you can see that these are all carbon composition resistors. So if you were to work on this thing and the guy was really set in his ways, you would want to replace those with carbon composition resistors again. If he's not too particular, you know, a lot of these resistors could be replaced with a metal film resistor or carbon film resistors. Things like that. There's a lot of other resistors that could be put into place in here. The customer, again, if he wants the thing to be as original as possible, you want to do your best to try and keep it like that. Now, in a case like this, you can see that these are electrolytic capacitors in here, and all the electrolytic capacitors by now are definitely needing to be replaced. So this thing would need electrolytic capacitors. We see these blue style capacitors all over the place in this Fender amplifier. So say you have opened this amplifier up and you've never come across these blue capacitors before and you're unsure whether you should replace these things. If you use your old I-tube tester and test them for leakage on an old I-tube tester, You know, it may show leakage, it may not at this point. If it doesn't show leakage, do you know that these things are going to be dependable? Would you want to let this thing go back onto the road? Would you like to let the guy go and say, do a gig with this thing, you know, with that at the back of your mind? You know, I just worked on this amplifier and, you know, I don't know, you know, is the thing going to fail on stage? I didn't change those caps. So what we're going to do is I'm going to show you a very simple way to test these with this new forecasting tester that I've created, the low voltage leakage tester. That'll give you a very, very good sense of confidence with capacitors. So I'll get that all set up and I'll be right back. We want to find out whether we're going to need to replace all of these dark blue capacitors or whether we can leave them in circuit. There's bound to come a time when you open up a piece of gear, whether it's an amplifier, piece of test gear, radio, whatever, and you're going to see a whole bunch of capacitors that you just don't recognize. These things come in so many different shapes, colors, and sizes. You're bound to run across a bunch that you're just going to look at and go, okay, is that a poly capacitor? Or maybe it's a dye film capacitor and it's getting slightly leaky. Maybe they should go. So we're going to use this leakage and forecasting tester to verify these capacitors here. We want to go past the leakage test with this capacitor, and we also want to use the forecast test on this to see if this is going to be good down the road. So we can actually forecast whether these capacitors are going to start leaking. The forecast setting on this capacitor tester is so incredibly sensitive that even if there's just a minute amount of decay, or whether this thing is leaky or whether there's any type of moisture ingression that has got inside this, this is going to show this, no problems. So I'll show you how to do this, and there's even a little shortcut to switch between the leakage and the forecast test to kind of speed things up. So the first thing I want to do is remove just one end of this cap. So I can leave the other end in circuit. If you feel more comfortable taking the entire capacitor out of the circuit, you can do that as well. So since this is still attached into circuit, I want to take the positive lead of this tester and attach it to the end that's still in circuit. If I put the sense lead on this side here, what it's going to do is it's going to run off through the wiring and all that and through some of the rest of the circuitry here, and it's going to give me some false results. So the positive lead always goes to the side that's attached into circuit. The sense lead goes to the open lead. So I'll put this here. Like so. So now what I want to do is I want to click this onto just the paper and poly position, and I want to see whether the LEDs are going to come down and this is going to go to a green light. But I can kind of cheat in the middle of the test. So when these LEDs start to drop down like this, and say it gets to the middle here, what I want to do is quickly click this to the forecast position, which would be the center position. So by doing that, I'm kind of mid-scale already, so somewhere when it's on the scale here. If I click this to the forecast position and the LED stops and climbs up again, or it just goes off the scale and doesn't come down again, we know that this capacitor is going to have to be changed. So we're giving it a leakage test. We can see that it's going to climb down. If we click it onto the forecast position is an extremely sensitive setting. If this keeps going down on the forecast position, I know that this capacitor is going to be okay to leave behind in the circuit. All right, so I'll give you an example here. So what I'm going to do is I'll just click this right on so that the center position is on and discharge, and then this is, when I click this up, it's going to go into the test position here. So this is going to pin out. And since this is 0.1 microfarad at 600 volts, it's going to take just a little bit for this to start counting down. Again, when it gets to mid-scale, I'll click to forecast. We'll see how this capacitor, or what condition this capacitor is in. So here we go. So I want to wait till this starts to come down on the scale here, and that's a good indication that I can click it into forecast. So if this is good, this should start counting down any time like it is. So now I want to click that to forecast. You can see it's still going down in the forecast. You see it slowed down because it's so sensitive. That capacitor is good to go. That is not going to fail anytime soon. there is extremely minimal leakage inside this capacitor here, so this is most likely a poly-style capacitor. So what I'll do is I'll remove this here and I'll move to one other capacitor. We'll verify one other capacitor. If I've got two of them that do the same thing, we're good to go. Let's test this one right here. It's right beside the other one. Good idea, just move that out of the way. Hopefully this one comes out of the board as easy as the other one did. No problems. A little bit of wax on that lead there. Okay, so what I'm going to do now is put the positive side to this side here of the tester. Put that back into that other position there, so this is back in the paper and poly position. I'll clip this here because this is the side that's in circuit again, so this side here is out of circuit. So I'll clip this to this side right here. Again, what I'm going to do is turn this thing on so it's again in the paper and poly position, and when this comes to mid-scale, I'll click it to forecast. If it keeps going down, we're good to go. Let's try it out. It's 0.1 at 600, same rating as the other one. So it should start coming down any time now. Okay. Forecast. These caps are really good. No problems whatsoever with these things. So yeah, I'm very confident that these things are a poly-style capacitor and they're going to be just fine to leave in circuit. Let's test these smaller electrolytic capacitors to see if they test good for capacitance. Now, of course, they're going to all need to be changed out because they're going to be leaky by now, just like the capacitors on the top side of the chassis underneath that cap. But we're going to chase a signal through this thing, so I just want to see if they're okay enough to do that. Now, most of these capacitors are going to be cathode bypass capacitors. So they're going to have a relatively low resistance in parallel with them. You can actually see it right here. It's right across it. 820 ohms across that one. Looks like 1.5K across this one here. Now here's a catch. A lot of engineers and techs don't realize that not all meters are created the same. Some meters are perfectly fine to test these capacitors in circuit with this really low resistance, 820 ohms, right across it. Whereas other multimeters will get pretty upset when you try and test them in circuit. Here's an example. Here's my really nice Agilent 1253. Hopefully you can see that display. Yeah, it's a little bit dim. Lots of light here. So what I'll do is I'll test this one right here. 820 ohms right across it. And watch what happens. This is common for a lot of multimeters now. Not very happy. It says, I don't want to test this. So if you have a dedicated LCR meter, their circuitry is a little bit different inside. So here's a dedicated LCR meter. All right, this is a DLM 240. I've had this for a long time now. I'm not sure if these are still available or not. The reason I got this is because I can test modulation reactors up to 200 henries. So back when I was working on that kind of stuff a lot more, very, very handy test, especially for Heising and modified Heising circuits. So I'll turn this to 200 mics. We'll do the same test right in circuit. So 25 microfarad capacitor at 25 volts in parallel with an 820 ohm resistor. Negative side here, positive side here. No problems. Look at that. Just that fast in circuit. Now, since these are cathode bypass capacitors here, these are cathode bypasses, and these will be cathode bypasses. This one here I don't think is. But at any rate, since these are all cathode bypass capacitors, I can take this off. This is just going to be going to ground or chassis. So I'll just clip this onto the chassis here. And as you can see, again, I'll test this one here. No problems. Let's move to the next one. No problems. Let's move to the next one. no problems. So they're all testing okay for capacitance. Let's test, there's 2 down here as well. No problems. And this one here looks like it's going to be a little bit more difficult to get at. Let's see if I can touch that. Yeah, no problems right there. This one here is 5 microfarad, and this one here looks like it might have actually leaked a little bit. So when they do leak, they usually test a little bit higher in capacitance. So let's see. Actually, I'll zoom in on that. Well, I'll zoom in on it here in just a second. Show you what I mean by the leaking. It's testing at 9 microfarad, and it's supposed to be 5, so yeah, chances are it's a bit leaky. It's still working, though. See what I mean by the leakage here? You can see how it's discolored on the side here. So it should be this way all the way through, and it's kind of got this discoloration over here. So those would definitely all need to go, but again, you know, for us to chase a circuit through this thing, it should be absolutely fine. Another thing to keep in mind is when you see these disc capacitors, these things rarely fail. These things right here. Don't worry about changing these things out. You can test them if it makes you feel more comfortable. This one's rated at 1 kV. But these things very, very rarely fail. So I found one of these not long ago in a Tektronix oscilloscope. Actually a big, what was it? It's a 535. It was a Tektronix Type 535. And it was a 25 volt rated cap. It was a ceramic cap like this rated at 25 volts, and it read 8 ohms. So one of the rare occasions where I found a ceramic capacitor that was shorted, so that must have been something that was, you know, a failure in production. Maybe there was a thin spot and something happened, or something odd happened within that capacitor to make it short. But again, like these capacitors here, they all rarely fail. Let's do some signal tracing. I'm going to show you how to follow the signal all the way from the input jack through the circuitry to the output tubes and what to look for in the circuit so that you can get to the output tubes and follow the signal with ease. Now here's the thing, you can use the simplest oscilloscope to do this. It can be an old vacuum tube oscilloscope with no on-screen display. The trick is just knowing what to look for, and I'm going to share that with you here in just a moment. It's a few simple things, and if you can just remember these simple things, you'll troubleshoot audio amplifiers lightning fast. Before I get going, I need to warn you about vacuum tube amplifiers. If you're new to this, if you haven't worked on vacuum tube amplifiers, you need to know this. There's high voltage all over these things, scary amounts of high voltage. This has got over 500 volts in this amplifier, and there's a lot of current here. If you come across that, it could be fatal. So if you're working on an amplifier like this and you're unfamiliar with this, do not power it up. Study the circuitry first, get to know the amplifier, and the thing is, if you're unsure about yourself, don't take the chance. All it takes is once. There is a lot of current supplied by that very large power transformer down there, and there's a lot of voltage and current available at this rectifier right here and all over the circuit. The high voltage is all over everything from end to end in this thing. It's not like a solid state amplifier. Vacuum tube amplifiers have got deadly voltages all over the place. Audio amplifiers are bad. Transmitters are really bad. It gets worse and worse. Some of the older radios have got really high voltages in them too. Usually not 500 volts DC like this thing, you know, and they don't have such a monstrous power transformer. Again, this thing makes 135 watts RMS, right? It's designed to put out a lot of noise. So this thing has to supply a lot of current to make that kind of noise. It has to drive some pretty big speakers. So if you're following along, you're doing so at your own risk. All right, let's do some signal tracing. This is a very enjoyable part of troubleshooting. We get to follow the signal all the way from the input through the amplification stages to the output section. We get to see how that signal's amplitude changes as it goes through controls and all sorts of things. So we're going to be taking a look at the normal circuit here. That's this circuit right here. We're not going to worry about the vibrato circuit. So we have to contend with these controls here and this control over here, this being the master volume control. So we have a volume control here in the preamp section. We have a bass, middle, and treble section right in here, and we're just going to set those all at a center position. So these are all at number 5. I think you can see that on the camera there. The main, or the input volume control here for channel, the normal channel, is set at about 8. Not really too particular, just, you know, pretty much 3/4 the way up. Here's the thing. You want to make sure the master volume control is right down. That's the very first thing you want to make sure that's down. This amplifier, again, makes 135 watts RMS, and I have my little test speaker attached to this. This thing would annihilate my test speaker in a blink of an eye, so I want to make sure that this is down. So my audio signal generator is set to, just over 300 cycles, and that signal is being fed into the input jack here. So you could still, you know, you could feed the signal in through a 1/4-inch jack in the front. I've just tied my alligator clip into this point here, which is running into the circuit, same sort of deal. The amplitude on my audio signal generator is turned right down. So the volume right in the first section is turned up to number 8. These are all sitting at a mid position, and the master, as you can see here, is at number 1. I think you can see that on camera. It's about number 1 right there. So what I'm going to do is turn on my isolation transformer and variac supply. So I'll turn that on right now, and I'll let the amp warm up here. I'll turn on my little oscilloscope. And I see tubes glowing. We're on our way. So give it a few moments just to warm up here. These are vacuum tubes, and you need to warm up for just a second. And I can hear the tone in the speaker already with the amplitude all the way off. Wow. That's up just a touch. So this is the master. That would just destroy my speaker. You can see that I'm at number 1, approaching number 2, and that's very, very loud. So this is into a speaker right now, and of course, if we were going to be giving it this type of amplitude, here's an example of needing a load. So you can hear there's just a little bit of signal right there into the speaker. That's fine. We could probe the output jack without a speaker. You know, disconnecting the speaker isn't going to hurt anything. Giving it this much volume here, it's just audible. It's not too incredibly bad. Disconnecting the speaker is not going to hurt anything. Giving it amplitude like that, now it's starting to get pretty loud. Now you would want a load on there. You wouldn't want to not have any load on this. So what I'm going to do is just get rid of this so we don't have to listen to that horrible noise. I'll just put this load on here. So that way I've got a resistor acting as a dummy load, so I don't have to listen to that horrible noise. So I'll just turn this down, leave this right down at the bottom right now because we don't really need to worry about the master volume. That's basically just turning the signal on to the outputs. So online, you can find the schematics for these amplifiers very easily. The trick to troubleshooting amplifiers like this is just remember signal in the grid, out the plate. In the grid, out the plate. The signal path is very easy to follow in this amplifier. You can see that they've drawn the grid here as a squiggly line. Now, a lot of the times they don't do that. A lot of the times it's a dotted line, squiggly line, same thing. The cathode is the C that's facing downwards here, and the plate is the part with the high voltage on it here right at the top. So when you're drawing tubes on a schematic, usually if you're drawing an amplification chain, the plate is on the top and the cathode is on the bottom. There are some exceptions in phase inverter circuits. When you show 2 of these, you can see the cathodes are tied together for ease of drawing, and you can see the plate down here on the bottom. In most cases, as you can see with most of the tubes, the plate is always drawn on the top side. They're not drawing the tubes upside down, right? So signal in the grid, it's going to get amplified. We're going to see a lot more amplitude on the plate. If we do see more amplitude on the plate, we know that the tube is amplifying. It's just that simple. We don't need any fancy test gear. We don't need any on-screen display to do that. We're just looking for amplification. If it's amplifying, chances are it's working okay. I'd say 90% of the time at any rate. So the path is into the jack, into the grid here. So that's where this signal is running in over here. Okay, so I've tied in directly at the grid right here. You can see that I haven't tied on the other side of the 68k ohm resistor. So the signal is being fed directly into the grid. So it's going to there's going to be quite a bit of amplification on the plate here. We're going to see a nice big signal here, but we're going to lose some of that amplification through this tone network here, or tone stack if you want to call it that. So what we'll do is we'll see a lower amplitude on the grid here again. We don't need to worry about that. We just want to check for amplification. We want to see if the signal is here. If it is here, we want to see amplification on the plate. And we can just follow the path all the way through. This is the master volume control, so that's this control over here. The signal is going to come through here and go into the phase inverter circuit, and then we're going to have two signals here 180 degrees out of phase. You can use two channels on an oscilloscope to verify that. If you're just looking for signal, which is pretty much all that's really important at this point, we just want to make sure the amplitude is the same on this, and we can use any old oscilloscope for that. So I'll give you an example here. So the signal is going to be coming into the grid here. So I'll give my signal generator just a little bit of amplitude. So as we can see, the signal goes in pin number 2 and comes out pin number 1. So you want your oscilloscope AC coupled, sensitivity set accordingly so that you have a comfortable view on your screen here. So when you're counting vacuum tube pins, so this is vacuum tube number 1, number 2, number 3, 4, 5, and 6. There's another thing here I should explain really quickly. You can see how it says V1A, and then it says V1B over here. See, V1B and V1A. So all that means is this is vacuum tube number 1, and there's two parts in that one vacuum tube. So this is part A and part B, so one triode and the next triode. So if we look at the schematic, we can see that the signal goes into V1. All right, it goes through a tone area here into the other triode in V1, so we're basically staying within this one tube over here. And then it jumps all the way over to V6, which is right over here, the phase inverter, just before the audio output tubes. So we're missing all these other tubes. These other tubes here are part of the vibrato circuit and, the reverb and all that kind of stuff. So we'll just keep it easy this time. We'll just follow this circuit here right over to the finals. Now, what I'll do, again, is I'll probe number 1. All right, so we'll take a look at V1 here. We'll look at pin number 2 and pin number 1. So we're going to have a lower signal on pin number 2 because it's right out of my signal generator. And then when we get to pin number 1, we should have a really big amplitude because it's being amplified. Okay? When you're counting tube sockets, you always count clockwise from the index. So if you're looking at a vacuum tube socket, the opening in a 9-pin socket here is where you start counting. So the first pin on the left-hand side is pin number 1, and you count clockwise to pin number 9. So that's looking at the bottom of the tube socket. So pin number 2 is where the signal comes in, okay? So there is the signal from my signal generator right there on the oscilloscope. So what are we going to expect to see if I go to pin number 1? Again, your scope is AC coupled while doing this. So what am I going to expect to see? Well, if we see amplification, we're going to have a lot more amplitude. This is going to probably go right off the screen. Okay, so I'll go to pin 1. Look at that, it's right off the screen. So I have to turn the sensitivity down. Look at that. Lots of amplification there. We know that that stage is amplifying. Just that simple. We don't need any on-screen display or anything like that. So if I turn my signal generator down, you can kind of see I'm overdriving it just a little bit. Turn my signal generator down just a hair. So now that I've set the sensitivity down on this, if I go back to this pin over here, you can see that I virtually see nothing. That's how much this is amplifying. So I have to turn the sensitivity of my scope way up to see that signal again. There it is. Again, if we go to the plate, it's just going to go right off the screen. So much amplitude. So you just turn the sensitivity of the scope down. Just that simple. We verified that that part of the triode is amplifying in the grid, out the plate. So now we want to go to the next stage here. So we want to see if we're going to get any signal at the grid here, which is pin number 7. And then we're going to want to see if this is amplifying. So we're going to go to the plate, which is pin number 6. So in the grid, out the plate. So in number 7, out number 6. So now, because we're going through this tone area here, we're going to lose amplification again because it's going through a whole bunch of circuitry. That's just how it goes. So we're going to probably have to adjust the sensitivity of the scope. So we want to go to pin number 7. So we go 9, 8, 7. So this is pin number 7 right here. Let's turn my probe around a little bit. 9, 8, 7. There it is. So you can see the amplitude is down again, right? So if we go to the plate of the last stage, you see how we got big signal here, right? We go to pin number 7 because we're going through these controls up here. It's down again. But you can see the signal is there. I'll just try and clip this on there. So you can see that the signal is there. If I turn this back down, you can see that we have a signal there. And you can see there's a little bit distorted as well. Of course, this stuff being desirable. Turn that down. This is the main volume control on the front. You can see that? You can driving it into distortion now. This is the kind of stuff that guitar guys are looking for. So there we go. So we can see that we have a signal there. It's down at about number 6. I'll just leave that at 6. Nice clean signal. So now that's at 7, right? So now we want to see if this is amplifying. So we're going to go to pin 6. So what's going to happen? The amplitude is going to go high if this is amplifying. Okay, so I'll just go to pin number 6, put the schematic down here, and over to pin number 6. And look at that, it's right off the screen. So I'm going to have to turn the sensitivity down again. And we know that this stage is amplifying. Just that simple. We've followed the signal all the way to this point already. Just that fast. Now, if we want to see if the phase inverter is working, this is when it's important because we have to go through the master volume here, right? So if I start turning this up, I can probably hear the audio transformer in this. I don't know if you can hear this. Hear that? I don't know if you can hear that. That's the audio transformer making noise, right? There's quite a bit of amplitude there. So in order to, this resistor will get hot really, really fast. So in order to see if the phase inverter section is working, all we need to do is we can probe the 2 plates of the 12AT7 here, V6A and V6B, and we should have roughly the same amplitude on each plate if these resistors are, very well matched. As you can see, the plate voltages are the same. Now your scope is AC coupled, remember, so you have to remember that. If it is DC coupled, this will just shoot off the screen. So these are the 2 47K resistors right here. You see those 2 wires? I'll just get a little pointer here so I can point to them. A nice insulated pointer. So this is where we're going to probe. This is the plates of both of the triodes here in the phase inverter. So again, we're just looking for equal amplitude. So what I'm going to do here is just remove this. I'll move my probe over here. And we'll go here. Now, in order to see anything on the scope, I'm going to have to turn up that master volume control again, right? Because you can see it's in the audio path here. So if this is down, we're not going to have any signal over here. So we'll turn this up. And look at that. There it is. No problems. So in order to not have to turn the master volume up too high, I'll just turn the sensitivity of the scope up here. So there we go. So that's one side, and we should have roughly the same on the other side. So I'll just move from this resistor to this resistor. And there it is. No problems. So we're going from this side here to this side here. Just that simple. And back to this side. A little bit of amplitude difference, not too bad. Working pretty good. That's how easy it is to follow the signal right to the grids of the output tubes. Next, we would be pretty much looking at the speaker, right? We don't need to probe the plates here. There's really high voltage on there. So, we're right at this point to where the signal is going into the grids of both of these 6L6s, so it would get amplified and come out the audio transformer. You can pretty much test that with a speaker, right? Because if you got signal at this area here, if you hook a speaker up here, if these tubes are working okay, you're definitely going to hear something like what we heard earlier. It's just that easy. So I hope you enjoyed following along through this entire troubleshooting procedure here, and you enjoyed all the hints and tips and tricks and things like that. going about repairing this and changing all the caps and, you know, doing the final testing and everything in this episode would make this video incredibly long. Has to be a lot of time spent in this amplifier to change out all these capacitors and to go through the whole thing. And, you know, of course, I'm going to want to check all the resistors. I want to check everything to make sure they're in spec. You know, I see that there's a little bit of amplitude difference in the phase inverter circuit here, so I would be checking that. Maybe I would, you know, maybe it's the vacuum tube itself. One triode might be a little stronger than the other, or maybe the plate resistors are a little bit different. You know, there's a difference in resistance there. So these are the little things that I would look into. But this, you know, doing this in this video greatly exceeds the scope of this video right here. So I may actually put this thing back onto the, you know, the floor here and do an entire video on this thing here very shortly. Just pretty much changing out all the components that need to be. And if I do that, I'll bring you guys along through that process as well. I hope you enjoyed this video from the Super Electronics Troubleshooter series on Patreon. If you learned something today, you can let me know in the comments below. And if you think that my troubleshooting and repair skills will benefit you, you're definitely going to want to check out my Patreon site. When you join Patreon, another tab will appear underneath the picture of my lab. It's called the Community section. In that section, you can share your own projects with the other members in the community. You can post pictures there and even ask questions to the other community members as well. So there's a lot of really neat things going on up there right now. All right, I hope you enjoyed. I'll see you soon. Bye for now.